Hello, today we're going to take a look at this budget sample where we are computing the cost of producing corn and the cost of producing pigs. Um, I may need to do a second video to catch all of this material, but in any case, let's go ahead and get started. Okay, unlike previous budgets, I actually have you do some more work today to similar to what you would do if you were managing your own farming operation. In previous examples, I have had your expenses pretty much lined out for you, and then all you have to do is add them up. So here you're going to do some more work. Let's go through this together. What you see is that here we have a production of 180 bushel corn at $4 a bushel. We have land at $250 per acre rent, and then we had these machinery expenses. Now, what I have you do in this case, to save time, save a lot of agony, is to just simply estimate your machinery costs by using the custom rate survey. And the custom rate survey should be in your packet. You should have one in your packet, but it's also available to you. Um, in Brightspace, you can access it, or just go to Ag Decision Maker. It's updated every single year. I am making this video in the year 2017, therefore I'm using the 2017 custom rate survey. And it's pretty simple. You just go through the listing of machinery operations and then use the average charge. Okay. So I'm going to leave it there and just tell you here's all the expenses that I found off the custom rate survey, and I added those in the I'm going to make everything on the cost per acre basis here so you can see that. But hauling grain, I gave you 11 cents a bushel. Well, on the per acre basis, I'm going to multiply it by 180 bushels. That's my production. 180 bushels per acre times 11 cents equals $19.80. Drying the corn, 3 cents per point of moisture per bushel times 5 points. So we're saying that we're going to harvest our corn at approximately 20%, dry it to 15.5 if we're going to sell it. That costs us 3 cents a point, we figure. So 5 points times 3 cents a point is 15 times 180 bushels per acre. I'm at $27 per acre. 20 cents of storage times 180 bushels, 36 bucks an acre. Seed corn. Our seed corn cost, they give it to us in price per bag. In this example, it's $350 a bag. And we plant a population of 32,000. 32,000 is not a whole bag, obviously. And the price is for a whole bag. So what we do is just take 32,000 divided by an average seed corn bag of 80,000 to get the percentage of a bag that we're planting per acre. Multiply that by price per bag. We end up with 140 bucks an acre there. Now, probably the trickiest part of all is our fertilization calculations. What we're going to do here, first of all, I give you the removal rates of crop nutrients, and what that means is if we have an optimum soil test, we need to fertilize 1.2 pounds of N per bushel of corn that we plan on harvesting, 0.375 pounds of phosphorus per bushel of corn produced, zero point 0.3 pounds of potassium per bushel of corn produced. So we just take each one of those nutrients times 180, gives us the total pounds of N, P, and K that we need. As we look at the fertilizers, our fertilizers are not 100% N, P, and K. So we need to figure out exactly how many pounds of fertilizer we need. And we're going to fertilize for diammonium phosphate first, because as you can see, diammonium phosphate gives us 18% nitrogen, 46% phosphorus, and 0% potassium. Always remember, the fertilizer analysis looks like is described in percents of nitrogen, phosphorus, and potassium. NPK, nitrogen, phosphorus, potassium. Anhydrous ammonia here, 82% nitrogen, 0% phosphorus, 0% potassium. Diammonium phosphate is 18% nitrogen, 46% phosphorus, and 0% potassium. K, or potash. K is the chemical symbol for potash, or for potassium. That's 0,060, 0% N, 0% phosphorus, 60% potassium. So, how do we solve for this? Well, we don't know how many pounds of fertilizer. That's X, or N, not meaning nitrogen. N pounds of fertilizer times 46% phosphorus needs to equal 67.5 pounds of phosphorus. Well, how do you solve for N there? You take 67.5 and divide by 0.46. And that's what I have done down here. Always remember, you take what you want as far as pounds of fertilizer and divide it by what you got. In other words, the percent of your fertilizer that is the specific nutrient. So what we want is 67.5 pounds. We divide that by percent. What we got, 46% phosphorus. So we need 147 pounds of diammonium phosphate. We'll come back and figure out what that costs us in a second. In the process of giving us 46% phosphorus, we also get 18% nitrogen. So what we do now is take the 140 pounds of diammonium phosphate, multiply that by 18% nitrogen, we get 26.5 pounds of nitrogen that is supplied in the process of meeting our phosphorus need. Okay, so we'll use that down here in a second. The cost of our diammonium phosphate is 147 pounds. Our price is in price per ton. So what we do is just simply take $600 per ton, divide that by 2,000 to get our price per pound of fertilizer, and multiply that by pounds of fertilizer. From there, we determined that we needed it cost us $44.10 to meet the needs of our phosphorus. For nitrogen, we determined the total N to be provided by anhydrous. We needed 216 total pounds of N. We already determined that we got 26.5 pounds from the diammonium phosphate, so we need 189.5 pounds from anhydrous. Again, what we want by what we got. Take pounds of N that we need, divided by 82% N anhydrous, gives us 231 pounds of anhydrous that's needed. Again, the pounds of fertilizer needed times price per pound of fertilizer. The price per ton divided by 2,000 pounds gives us the price per pound of fertilizer. 231 pounds times price per pound gives us $72.77 as the cost of anhydrous. Now we go to potassium that's going to be supplied by potash. What we want is 54 pounds. What we got is 60%. 54 divided by 0.6 is 90 pounds. 90 pounds of potash times $440 divided by 2,000 pounds, or 22 cents a pound, gives us $19.80 to meet our potassium needs. So make sure you read through that. If you have any questions, drop me an email or give me a call. Herbicide, 16 ounces of XYZ herbicide. It's priced at $300 a gallon. There's 128 ounces in a gallon, so let's figure out how much of a gallon we use. 16 ounces is a pint, by the way, but 16 ounces divided by 128 ounces in a gallon times $300 a gallon equals $37.50. 1 pint. Okay, so that's $37.50 per acre cost of herbicide. If we use 1 pint per acre of crop oil at $12 a gallon, remember that there's 8 pints in a gallon, so 1/8 of a gallon times the price of a gallon gives us $1.50. The crop insurance I give you is $22 per acre, so we need to add that in. So in this problem, I'm going to add up my rent, my machinery costs, my drying, my storage, my seed corn, my fertility, my herbicide, and my crop insurance. And I do all that and I get a total cost per acre of $789.07. To figure out my cost per bushel, I just divide cost per acre by total bushels. And I told you up here 180 bushels per acre. So 789.07 divided by 180 bushels per acre, $4.38. Hopefully this was helpful to you. As always, if you have any questions, feel free to give me a call, stop by my office, drop me an email, and I'll do my very best to help you out. So thanks a lot and good luck.